So we are going to continue on with the rate of change. So the goal for today is to calculate the ROC, or what we call the rate of change. At which something is changing and the ROC is often indicated by the slope of the graph. So rate of change is the same thing as finding the slope, right? So if you remember, slope is, do you remember the formula for the slope? M is the slope. Okay, that's the equation of the line. Do you remember the formula to find the slope? It's the rise over the run, right? So it's a change in the y versus the change in the x, right? Which brings it to the y2 minus y1 over x2 minus x1. Okay, so we'll talk about that. So the independent variable, them x1, x2, and your dependent variable are y1, y2. So your point A is x1, y1. And point B is x2, y2. Right? So if you look right here, if I want to find the slope of the line, I have to look at the rise versus the run between the 2 points. Okay? That's what slope means. It's how steep is your line. Okay? To find that, if I'm looking at my rise, that means I'm looking at the difference between the y values, right? Because this is my y value for B, and this is the y value for A, right? So I'm looking at the difference in this that will tell me my rise, versus my run, which is the x value of B and the x value of A. Okay? So to find the slope, or the average rate of change, we do the rise over run, or in other words, we do y2 minus y1 over x2 minus x1. So the difference in the y versus the difference in the x. Now, if I look at the slope of the line, or the average rate of change, it tells me what kind of graph I have. It tells me if I have a linear graph or if I have a nonlinear graph. Okay? So whenever I'm looking at the average rate of change, okay, or the slope, if the slope is constant at between every single point, then I will have a linear function. If my slope is not constant, then I don't have a linear function. Okay? So let's look at this. Calculate the average rate of change between each pair of points. Explain what the rate of change means. So they just gave me 2 points in minutes, airplane in height, and then they gave me time 0 is 2,000 meter, time 4 is 1,400 meter. They want me to find the average rate of change. So what do? What's the formula for the average rate of change? Yeah. So remember, these are my x's, and these are my y's. So y2 is 1,400, y1 is 2,000, over x2 is 4, and then x1 is 0. So that's going to give me negative 600 over 4, which is going to give me negative 100, 1.5, sorry. No, 150. Now, the difference between a slope and an average rate of change is that an average rate of change is going to have units. Okay? So if I'm doing y over x, what's the unit for y? What's the unit for my y? What's the unit? Is it in minute? Is it in meter? Is it in kilometer? It's in meters, right? So it's meters per minute. Yes? Because I'm doing meter divided by how many minutes? Right? So my unit here is negative 150 meter per minute. So what does that mean? What's happening to the airplane?
Going down.
It's going down 150 meter per minute. Right? That's what negative means. Negative means you're going down. So the height of the plane is decreasing by 150 meter per minute. So this is given 2 points. You can use that to calculate the average rate of change. Okay? The second example I have is a vehicle rental cost. So the distance driven versus the rental cost. So how many kilometers you drive, and then you're going to be able to calculate the cost, right? So they gave me 2 points on the graph. They gave me that if you drove for 200 kilometers, you're going to pay $400. If you drove for 400 kilometers, you're going to pay $700. How do I find the average rate of change? I can do rise over run, right? So my rise is going from 400 to 700. So that's 300. And my run is going from 200 to 400, that's 200. Or I can do the same formula, okay? So I can do the same formula with finding the average rate of change is y2 minus y1 over x2 minus x1. So that's going to be 700 minus 400 over 400 minus 200. So what does that mean? That's 1.5 what? My y's is in what unit? Dollars per kilometer. So you're going to pay $1.5 per kilometer. Okay? So the rate for each kilometer is going to be $1.50. Are we okay with that? So the distance required to stop a car depends on the speed at which the car is traveling. Use the tables below showing the reaction distance and braking distance needed to stop a car on dry pavement for a given speed to answer the following. Calculate the average rate of change between consecutive points in each table and describe the rate of change revealed in each table. So it's asking you to find the average rate of change. So the average rate of change is y2 minus y1 over x2 minus x1. Okay? I'm not going to write this every single time. I'm going to write it only once. So if I look at this, y2 minus y1 over x2 minus x1, right? Because this is my second point minus my first. Second minus the first. So that's going to be 2 minus 0 over 10 minus 0. So that's going to be 2 over 10 or 0.2. Again, y2 minus y1. So that's going to be 4 minus 0 over 20 minus 10. 4 minus 2, sorry. Thank you. Then it's going to be 6 minus 4 over 30 minus 20. 8 minus 6 over 40 minus 30. So that's going to also be 0.2. And then 10 minus 8 over 50 minus 40, that's also going to be 0.2. So what can you tell me about the rate of change here? It is constant. Okay, so we're going to say that it's a constant average rate of change. And we know it's going to be, so basically the stop or the reaction distance so all we can say here is the reaction distance increases because it's positive by 0.2 meter per kilometer per hour. Okay, that's a little bit weird because you're doing reaction distance over speed. Thank you. So every time you are basically your speed increases by 1 kilometer per hour, then you need 0.2 of a meter more space to be able to stop. It takes you 0.2 meter more to stop. Okay? So if your speed is 1 kilometer more per hour, then you need 0.2 meter more distance to stop. If that makes sense to you guys. Can you guys do the second one? I'm going to write the answers down. . . So in this case, you see that the average rate of change is not constant. It's increasing average rate of change. So this is not going to be a linear function.